So this is, you have a particle confined in a box of length L. It is such that at x equals to 0 and at x equals to L, you have barrier, you have potential energy barrier, which is infinite. So you have two infinite wall, and inside it the particle is confined. The length is L. So the potential energy of the particle inside the box is 0, V is equal to 0, and outside the box it's infinity, and it cannot go outside. And so you can just divide this into three regions, 1, 2, and 3, and we want to solve this equation H psi equals to E psi, which is the eigenvalue equation or the time independent Schrodinger equation for the system. And we put down the equation like this. We just club together many constants shown here. Constant we club together here, 2me divided by h process square, and we call it k. Okay, and the equation looks like this. This is a second order ordinary differential equation, and we're going to solve this with the boundary condition that the wave function should vanish at the boundaries. So your x at your psi at x equal to 0 and your psi at x equal to L should be equal to 0. And you have also mentioned how this model can be connected to a chemical model, chemical system. Example was hexatriene. We will do more later. So now we can begin from where we finished in the last class, and so we'll write down here. Essentially, what you need to do, you need to just we want to calculate this equation. The equation is as follows. We want to solve this equation. The Hamiltonian operator H operating on the wave function psi of x is the time independent wave function because we are dealing with stationary state. That gives you E times the wave function value. Okay. Just one small correction. Stationary state, because we are dealing with a case like this. If I take the complex conjugate of the wave function, which is time dependence, multiplied with itself, and then this product is time independent. Okay, it does not depend on time. That's why this wave function represents a stationary state. We'll discuss this more later. So we have to solve this equation. And what was the equation we wanted to solve? Say for region 2, we need to solve, because for region 1 and 3, for 1 and 3, the wave function is 0. So the equation is as follows: minus h process square by twice n t2 I x by dx square, that is equal to E times. Okay, fine. And then we just take this constant on the other side, and we have an equation like this: d2 psi of x dx square equals to minus twice me divided by x square x. Okay, and what I'm going to do now, I'm going to define this as a constant, the whole thing here, and I'm calling this constant as k. And if you call this as k, then your equation becomes uh, some times I think. Psi of x now. What is the general solution of this equation? Can anyone tell me? You can write it in the chat box. Maybe you can write it in the chat box. General solution. Okay, yeah. Somebody says a sin x plus b cos x. Yes, I think we'll take that. We'll take that. So the general solution is a general solution for this equation is the one suggested by some. But before we take the general solution is this actually: a sin kx plus b cos kx. The general solution. Actually, if you if you take this one, for example, if I take this one only, a sin x, this is also a solution. If I take something like b cos kx, this is also another solution, isn't it? But a general solution is if you add them, if you take a linear combination of them, then you get what is known as a general solution to this equation. So let us try to, maybe we'll try this, but if someone wants, someone also can take this. This is also a general solution. If I take a times e to the power of I kx plus b to the power of minus I kx. This is also a general solution. But okay, I will take this form, a sin kx and b cos kx. It is easier, I think, to take this form. Okay. Now, what are the boundary conditions? The boundary conditions are as follows: that the psi of psi at x equal to 0, which we are calling psi of psi 0, is equal to 0. And if I take this general solution, if I put the value of x, the first term will give you 0 because cos sin 0 is 0, and your cos term will give you b. Okay, this is what you get 1. So what you get is that, what does it tell you? It tells you that, okay, that b is equal to 0. Are you following? Please write it. Please write in the chat box. Yes, I'm following. Okay. The next condition, you remember that on the other side of the box, you have this x equal to L, which is your psi of L, and that has to be 0 as well. And if I put this thing there, already we know that b is 0. We don't need to put this term. You don't need to consider this term. The first term we need to consider, it will be a times sine a times L. Okay. Now, if you have a situation like this shown here, that a sine kl here is A sine KL equals to 0. And this is possible when? This is possible when there are two possibilities. When A equal to 0. Now, if A equal to 0, the wave function becomes 0, no? Because if A equal to 0, then the point is I equal to 0, then if I put equal to 0 in this equation, you can see your wave function becomes 0. So this you cannot take. So this is not a solution, because if you take equal to 0, wave function vanishes everywhere for any value of x. So the other possibility is, I'm writing it here. Sorry for this. The other possibility is this. You know that the other possibility tells you that okay, your sine KL is 0. And this is possible when, and this tells you what? For example, if I take a value of k at k0, L is finite, you know, the length of the box. If k is 0, then sine 0 is 0. But there are many other possibilities. So general possibility is that k times L shown here has to be equal to n times pi, where n is an integer. So for the time being, the values for n are possible values for n are 1, 0, 1, 2, 3, etc. The following. Anybody has a problem? Tell me. So we're going to do everything rigorously. We're going to do all the derivation rigorously in this course. Okay, that is the philosophy of my teaching. I don't jump steps. Okay, so your k of L is equal to n pi. Okay, and to begin with, n could be 0, 1, 2, 3. But now again, think about n being 0. In this particular setup, in this particular problem, can n be 0? Can n be 0? That is my question.
No, sir, it can be 0.
Why? Why?
Because if it will be 0, then web functions, there's no possibility web function can be exist.
How it is coming? Can you tell me?
Uh, if n is equal to 0, so it will be whole function will be 0 everywhere, whatever the value of L will be.
Okay.
So it means particle not be exist anywhere, which is a which is a
For
trivial
example,
point.
if n is 1, then it is not a problem.
No, it's not problem and is accepted.
Okay, why?
Because for n value will be 0.
Yeah.
Its value, value can be vary with the L beyond the 0.
Okay. So the point is that if again I choose for this particular problem n equal to 0, which is mathematically possible, but again if I take n equal to 0 and use this value of n, then the wave function becomes 0 inside the box, so which is not acceptable. So for us, we cannot take this value n equal to 0. So we will take only values like 1, 2, 3. N is an integer, but starting from 1, 2, 3, 4, 5, 6. Okay? Is this clear? Okay. We have not discussed anything. Energy we discussed. Okay. Then like 1, 2, 3, 4, 4. Like this. Okay. Now let us now I think we'll just put this here. So now the solution is as follows. So we have a solution like this, that k times L equals to n times pi. So, k times l equals to n times pi. Okay. So, and you had a solution like sin a x. So that becomes equal to a sin n by x. Okay. Now, this is fine. Now, how do I calculate a then? Any suggestion? Write down.
From the probability.
Sir, we can normalize.
Yes. So how to get a? So you have to normalize it. So what is the condition for normalization? Actual, the condition, the strictly speaking, is that you have to take space and time part both, multiply with its complex conjugate, integrate all over space. But in this case, you don't need to integrate from minus infinity to plus infinity, because the function is 0 when x is less than 0 or x is greater than L. So you have to integrate from 0 to L. But again, this is equivalent of saying, because this is equal to actually, because in a stationary state, it is equal to, actually this is this side. This is equal to your psi star x times psi x dx. Okay, so if I do this integration, what I'm going to get now? So this is very obvious, because what I'm going to get in this case I'm going to get, and this has to be equal to 1. This is normalization condition. So normalization condition. And what I'm going to get here, I'm going to get something like a sin n by x by L. I have to take the complex conjugate of this guy multiplied with itself. Integrate it, and that should be integrated from 0 to L, and this should be equal to 1. And what is the complex conjugate of the wave function here? Because sine has no I, no imaginary I, isn't it? So the complex conjugate of this guy is going to be the same, and I assume that okay, my a is real. Okay. So if I do so, then what I'm going to get here, I'm going to get something like a square, which I can take outside the integral. I have an integration like this. And now I have to evaluate this integral. Any suggestion? How do you evaluate this integral?
Sin square theta equal to 1 minus cos 2 theta divided by 2.
Yeah, so that is a suggestion. So we go back to your school trigonometry. You know that, okay? If I write down this cos 2x is equal to 1 minus 2 sine square x, isn't it? As far as I remember. So that gives you sine square x is equal to half into 1 minus cos. This is I'm going to use. This I'm going to use here. And if I use this, what I'm going to get now? I'm going to get s square, it will be there, and inside the integral I have this. I can take half outside. So we are going to get 1 minus cos 2n by x by L dx. And now we'll evaluate this integral. If you evaluate this integral, what I'm going to get? I'm going to write 1 here. 1 equals to a square by 2. The first part will give me, I just integrate dx from 0 to L. So the first part will give me L. And then I have a square by 2. And then I have an integral of 0 to L cos 2n by x by L. And this is going to be what? Going to be actually L times a square by 2 and then minus 0. Because this integral is 0. How many of you know that this integral is 0? How many of you know? Write it down. See, this is a periodic function, and if you take a symmetric interval, where you have a whole period on integral number of period, then this function, if you integrate, you get 0. And if you want to do it mechanically, also you can do. How to do it? Not very difficult. I'll just show you because we'll encounter such integral throughout this course. So what I need to do, I need to do that. Okay. I know if I integrate cos x, what is the answer? Cos x dx.
Sin x.
What is the
Sin
answer?
x.
Sin x.
Sin x. Tell me.
Yes.
Cos x dx is sin x.
Yes, sir.
Yes. So it has to be sin x plus constant. If I don't have limit, but if the limit is fine. So essentially, this part will give you something like sine of 2n pi x by L, but you have to then divide it this by 2n pi by L, isn't it? And then you put the limit 0 to L. And you know that when this is equal to something like sine 2n pi minus sine 0 divided by n pi, so this is 2. Huh? Any problem? And this is equal to 0 because this is also 0 because n is an integer. Is this fine? Please write. Is this fine? Okay. Very simple. So what I get here, after doing so many things, I get something like here. I am writing it here. Sorry for this. What I have here is 1 equals to a square by 2 into L, and that will give me that a equals to what? A equals to, continue on, tell me. 2 by L and a square root of 2 by L. So I can take plus or minus. It is actually plus minus root over 2 by L, but let us take only the plus. Okay. So now we have the normalization constant. The normalization constant is root over 2 by L. So once I have it, so my solution becomes, your wave function is, or the particular box is actually over 2 by L into sine n x by L. Fine? Is this fine? Any questions so far? Well, we're going a little slow today, but then after some time we'll go a little fast. Yeah. So now we go to the next slide and then write it down. So we have the wave function now, but we remember that we had this expression k. What are the expression for k? Minus 2me by h plus a square, isn't it? That was k. Sorry, plus, not minus, plus. That was the expression for K. You check your note. So that tells you that if I try to calculate E from here, the energy here, it is A H cross S square by M. And what is K? K is, remember that K, because K times L is N times pi.
N
So
pi
K
by L.
N pi by L. So what you have here is actually N pi H cross S square by twice M. Okay, is it? I think that should be the one. Did I make a mistake? Any
It will be
mistake?
k square.
Yeah,
Sir,
should be
it
any
should be
square.
K
What
square.
did I do with the mistake? Tell me.
So 2me by h cut square, sir, will it be equal to k square?
Because I think it was k square.
Yes, sir.
It was k square, it is n square and pi square. This is fine now?
Yes, sir.
This is fine? Now this is the expression for energy. So this is the energy. So actually your energy now actually depends on this n. This is a quantum number. Because this n has values like 1, 2, 3, the integer. And En is equal to this. You want, I can put the value of H cross. H cross is, in some book they'll put the value there. If I put the value here, it's going to be n square, pi square, H square, 2ml square into 4 pi square. So this pi square will cancel. This will give me n square, H square, 8ml square. Maybe many of you know this form, but they're same, whatever the word you write. Okay? Is this fine?
Yes, sir.
Yeah. So now we have the expression for energy. We have the expression for energy. We'll see what is this energy. And also we have the expression for the wave function. So let us now calculate few quantities. Let us try to calculate few quantities. But before we do that, let us see how this wave function looks like. So if I take the value of this wave function now, actually depends on the quantum number. So we put subscript n here. It is given by this. Okay. Now, if I take psi1, what is the expression? Psi1 is 2 by L sine pi x by L. And let me draw the box. The box is between 0 and L. And let me calculate the values of this energy. E1 is what? It's going to be H square by 8 ml square. If you want to write everything in terms of H process square, it is pi square, H process square by twice ml square. So maybe this is some positive quantity you can see. So I'll assume this is your first energy level, which I call E1. Like this is E1. So the expression for the energy for this level is E1 equals to pi square H process square by twice ml square. What about the next energy level? E2. What is the value? Can anyone write it down? If you can write it down, that would be nice. I'm waiting. Somebody should write it down. Someone is writing 4 times E1. Yeah, the right. So it will be 4 times E1. So what I'm going to get here is actually 4, because you'll have n square times E1. E1 is this, which is Anyway, you know this. So maybe it is here. So let us stick to two values and then we'll do other things later. But you know that, okay? What will be the next one? E3. Maybe we can calculate E3. E3 is what? How much? Yeah, E3 is actually is 9 times E1. Anyway, we can continue doing this, but let us concentrate on the wave function. So this is the ground state wave function, isn't it? Because it's the lowest possible energy state, so we can call it ground state wave function. And let us draw this. How can we draw this? Now look it very carefully. When all the wave function should vanish at the boundaries. So at the boundary it is 0 here as well as here. Okay. And what happens between 0 and L to this function? What is the value? So if I take L equals to say x equal to L by 2, midpoint, what is the value? What is the value at L equals to say x equal to L by 2?
Root.
Whatever the value, tell me. It is sine of pi of L by 2. So it is
Root 2
sine
by
of pi by 2. What is sine 90?
Root 2 by
Sine pi by 2.
Sine pi by 2, what is the value?
1.
1.
1. But you have this normalization constant. So essentially it is a positive quantity. So you will see in this case the wave function is always positive. Are you convinced between 0 and L? If you are convinced that the wave function is always positive between 0 and L, psi 1, then say write yes in the chat box. Okay. And then we draw this. So essentially it is 0 at the boundaries, but then it becomes like this, and actually L by 2 it has the maximum value, and this looks like this. It's a very bad drawing, so I'll try to do it again. So it will go like this and go like this. Symmetric. It is hand drawn, very bad. But it's symmetric, and the peak is actually, this is your L by 2. What about the next guy? Next one, psi 2. Now psi 2 is root over 2 by L sine 2 pi x, and if I take x equal to L by 2, say the midpoint, what is the value of psi 2? Can anyone tell me what is the value of psi 2?
0, sir.
Yeah, because if you put x equal to L by 2, so it will give you twice pi times L by 2 divided by L. L will cancel, 2 will cancel. You get sine pi, which is 0. So a function is 0. Okay? Are you convinced? Okay. So now if you plot this wave function will look something like this. That it starts at the boundary, this wave function is also 0 at the boundaries. Here is 0 here, it is 0 here. But if I start from left, it will increase like this, and then it becomes 0 at n equal to 2. Then it becomes negative, and then eventually it becomes 0. Are you convinced? This is how it is. Psi 1 and psi 2. So essentially what I have here is psi 1. So what I have here is psi 2. So are you convinced? And then there is a point here where the wave function changes sign. Becomes 0 and it changes sign. to 0. And this point is called node. So this wave function is one dimensional, okay? And the node is what here? It is a point here. The node is a point here. So the node is a point here. Are you convinced this is a point? Somebody switch on the mic and tell me that you are convinced this is a point.
Yes, sir.
For one dimensional wave function, the node is a point. The point has what dimension? Can anyone tell me?
0 dimensional.
Yes. So if you have one dimensional wave function, then its node should be one dimension less. So this is a 0 dimension thing, the node itself. We'll deal with Hadron atom, we'll see how nodes come there. In this particular case, the node is 0 dimension. And what you should see that if I now plot for any arbitrary value of n, psi n, then how many nodes it should have?
N minus
N
1.
minus 1.
Yes, because you see for psi 2 it is 1. If you plot psi 3, you will see there are 2 nodes. So for psi n, there are n minus 1 number of nodes. Okay? So this is all about the wave function. How does it look like for a particular box and the energy. Now we'll calculate something like the average quantities. So average or the expectation value. So let us calculate the expectation value of, say, I want to say position. Okay, and I put 1 here. It basically means I'm calculating it for the ground state. So it is expectation value of x in the ground state. It basically means. So what is the definition? How do you calculate? I go back to our class notes. Strictly speaking, we should take the wave function which has space and time dependence. But we are dealing with stationary state here. Each wave function, each state is a stationary state, because in this case what we are dealing with, my wave function which is space and time dependent is given by a small psi n x into the power of minus so again we are dealing with stationary state. And let us now calculate this x. So because we are dealing in stationary state, so the wave function also the wave function is normalized. So I don't need to write the denominator. Denominator, remember what was that? In the denominator, it should have like this. I'm doing it for the ground state. I should have a quantity like this. 0 and L. And what is this integral? This integral?
1.
1.
1, because already I have normalized. This is 1. And in the numerator, we'll have something which we are going to write it now. So in the numerator, you will have integral of course 0 to L. But what I have here is I1 star x times the position operator, which is actually multiplication by x, nothing else. And then I1 x. So the x1 is going to be your 0 to L. Now look at carefully, this x is only multiplication. So whether I put it here or here or here, it does not matter. It's a multiplication. It does not involve any derivative or anything. What I have here is actually x times psi square x dx. Again, we have used the fact psi 1 square x dx. Maybe I will just change my handwriting bit. I should write psi like this. Okay. Because your psi 1 star x is equal to psi 1 x because your function is real. Okay, and I have to integrate this in order to get x, average x, or the expectation value of x. Now, even without doing this integral, I can tell you what is the value. So for that, I just go back to your picture. Just take, you assume that, not assume, you take the ground state psi 1, and psi 1 wave function is symmetric, and it is symmetric about what? About this point, this L by 2, this point. Around this point is symmetric. And psi star psi gives you the probability of finding the particle, isn't it? So around that point x equal to L by 2, psi 1 is symmetric. Okay, if you go left to that point or you go right to that point, your probability pattern is the same, isn't it? So it is symmetric around that point x equal to L by 2. What does it mean? It basically means that if I calculate something with an average quantity, such as in this case the position, if I want to calculate the average position of the particle in the ground state, the answer is what? Can anyone write it down or can anyone tell me the answer?
Yes, L by 2.
L by 2.
L by 2.
Yeah, it has to be this point, which is L by 2. It has to be not 0, it has to be L by 2. Because it is symmetric around that point for you understand, it is L by 2. So even without doing the calculation, I can tell you the value has to be L by 2 for psi 1. Okay. Now if I go to psi 2, what is the value? Remember, we are calculating average quantity, average value. Expectation value is an average value.
Sir, that will be same L by
Yes, the answer is correct. That will be same. So if I go to even psi 2, although at L by 2 the wave function is 0, but the average position, if I calculate for this state psi 2, it is again going to be that midpoint, which is L by 2. Because your probability is symmetric around that point. Because if I take psi 2 and square it, which will give me psi 2 square. So the psi 2 square would look something like, can you tell me how psi 2 square? Psi 2 square would look something like this. Isn't it? This is psi 2 square. This is L by 2. This is 0. This is L. So it is again the probability is symmetric around the point x equal to L by 2. And now if I calculate the average, the expectation value of x, it has to be that midpoint which is L by 2. So for any value of n, you tell me, for any arbitrary n, so the average value of x in this case is L by 2 because the box is between 0 and L. So if I have a box say between minus L by 2 and plus L by 2, what will be the average value?
0.
Yes. Isn't it? So it is essentially the symmetry argument that I'm giving you. So with the symmetry argument, actually one should see that we'll talk about symmetry a little more later. Don't want to complicate things now. So this quantity has to be 0, and not only that, if I calculate the average value of x for any state, for any arbitrary value of n, this is equal to be 0. Okay? One small question, maybe you can tell me. Now this, you have to remember that this, you have to see that this wave function, this sine of n by x by L, this is not an eigenfunction of position operator. This is very important, I should write it down. That root over 2 by L sine n by x by L is not an eigenfunction of position
Sir, the average
operator,
value is L by 2. We have written 0, I think.
operator X. This is a very, very, very important statement. If somebody comes and tells you that this is an eigenfunction of X, don't believe him. He or she is saying something wrong. And this you should be able to answer why physically. Why it is not an eigenfunction of position operator X?
Yes, sir. We can get, sir, here cos theta.
Louder, I cannot hear you.
Yeah, sir. Are you here?
I cannot hear you.
Hello.
Yes, it is very, very, I cannot hear you actually. The problem is.
Hello.
Yes, so you have
Yeah.
to speak louder.
Yes, sir. Sir, sin x becomes, sir, cos x.
What?
Are you operating
Sin
the-
X become cos X? No. Don't tell me all these things. Because when I take X and multiply X with sin X, it remains sin. It does not change anything. It remains the same. It does not give you
Yes.
a constant time sin X.
Yeah, sorry, sir.
This is mathematical answer. What is the physical answer? Arko Prabhu, tell me what is the physical answer? Akash Ghosh, who can tell me what is the physical answer?
Energy.
No energy, nothing. The physical answer is that if your wave function is an eigenfunction of X, it has to be localized at that particular eigenvalue, isn't it? It has to be peaked around that position, some particular value of X. Is it the case? It is everywhere, no? It is oscillatory. Somewhere it is plus, somewhere it is minus, doesn't matter because you are going to deal with psi star psi. But it is somewhere it is high, somewhere it is low, somewhere it is zero. But in order to have a wave function which is an eigenvalue, eigenfunction of X, the wave function has to be localized. And I mentioned this briefly when we talked about wave packet, that you create a wave packet which is localized at a particular value of X. It has to be that value, X naught, for example. Then only your wave function is an eigenfunction of position operator. So the example is not here. An example would be something like this. This is called Dirac delta function. Is delta of X minus X naught. And if I plot this function, and this is actually X equal to X naught, this point, then this function is peaked around this value X naught. Like this. And then this function would be an eigenfunction of X. But not the sin n by x by L. So this is not an eigenfunction of position operator. And maybe if you deal with the Dirac delta function, we'll see how it is possible. Because there is an identity, because if I take X, multiply this with delta X minus X naught, and if I integrate this all over space, okay, the answer is this. That is how it is possible. We'll do this later. But what is the point is your wave function, this sin of n pi x by L times root over 2 by L is not an eigenfunction of position operator X. So, but we can always calculate the average value, and average value or the expectation value of X is 0. Now, maybe I should also show this mathematically this is 0. How do you do this? So it is going to be 0 to L x times psi 1 square, and psi 1 you know root over 2 by L sine pi x by L. So root over 2 by L, root over 2 by L combine, it will go outside 2 by L, and you get sine square. And how do I do this integral? Any suggestion? If you have any suggestion, please tell me. Any suggestion? How do you do this? Write it down in the chat box. Again, I do the same thing, no? I just integrate 0 to L, and then you make use of the trigonometry. Yeah? So sine square x is 1 minus cos 2n pi x by L dx, but of course I have a factor of 2. So this will give me, the first term will give me 2 by L x into 1 by 2, which is taken outside. So essentially, and it will give me x square by 2. Isn't it? Yes. And 0 to L minus 1 over L integral 0 to L x cos twice n pi x. What is the first term? It will give me 2 will cancel. Okay. And when I put the limit, it's L square by 2 minus 0. So L square and L will cancel. It will give me L by 2. And this term will give me 0. Again, this integral is 0. Are you convinced that this integral is 0? Are you convinced this integral is 0? How many of you are convinced? Let me see. Okay, many are convinced. Okay, well, that's great. So let us again try to evaluate this integral. There is no harm evaluating this integral. What is the integral? Here, the integral is 0 to L x times cos twice n pi x. How do you evaluate this integral? There is a technique. Can anyone tell me what is this technique? Yes. So integration by parts, isn't it? Recalling your class 11, 12, I don't know where you learned, but integration by parts is like u dv equals to integral u v, that's v du. Remember this? How many of you remember? Okay. And how many of you remember this thing? For example, if I differentiate, say, cos x, what is the answer?
Minus sin x.
Minus sin x. This is going to be very useful here, because here what will be the first function? What will be the second function? What is u? What is v here? Which one should I take, v, and which one should I take? So actually this should be u, x, and cos of this thing should be your dv, isn't it? So this will give me, are you convinced? This will give me what? The surface term is going to be x times, now if I integrate cos, what I'm going to get?
Sin x.
Sin x. So basically if I integrate cos x, what I'm going to get is sin x. So you have to put dx as constant. So now, can anyone tell me, please, maybe the girl, I don't know, was there, but can you tell me what is the answer here? X times, you just follow this formula. You know this formula, no? This one. How many of you know this formula? How many of you? Very good. So when you do this course, you also brush up your math. Okay? This is very important. There is nothing so difficult here. So what is the answer here? X times cos of y. What should be there here? Tell me. What should I put here? It should be sine of.
Pi x by L divided by 2n pi by L.
Yes. Yeah. Who is this? Who is this?
Akash.
Yeah. Please be there. And then I have to put 0 and L, and then minus. Sorry for this combination of colors, but anyway. Then I have integral 0 to L. What is the integration? V du. What is V? Again sine. And du is actually 1. So what I have here is sine 2n pi x by L, and I have to divide, of course, 2n pi by L. Now what about this surface? This is called surface term or whatever. These limits. If I put the limits here, what I'm going to get here? You have already done this. Akash, what is the answer?
Yes, sir. This term will be a 0.
0, because again sine pi in
2n pi.
0.
Yeah, 0.
Now what about
And
delta? This is constant. It will take outside, but sine, if I integrate sine within from 0 to L, which is a periodic function, you know this is going to be again what? What is the answer? Akash, what is the answer?
second part, sir. Second part
Yeah.
also 0. Second part also 0. Some constant minus some constant 0.
It's also 0. You can do this actually. If you are not convinced, I want to do this again. So you have this 0 by L, 0 to L, sine 2n pi x by L x. How do you do this? So what is the formula? You remember the formula of sine x. If I integrate sine x, what I'm going to get? I'm going to get minus cos x.
Minus cos x.
But then you have to divide by 2n pi by L, no? And then 0 to L. So essentially what I have is minus L by 2n pi, which is outside. And then I have cos 2n pi L by L. So cos 2n pi minus cos 0. So I am doing all the steps. Nobody will do, because you see in the books, it is only just one or two lines, and then the answer is given. What is the answer to this?
0. Sir.
See, cos 0, what is the value of cos 0?
1.
1.
What is the value of cos 2n pi when n is 1, 2, 3, 4, like this?
It also 0.
Always 1.
1, sir. Yes.
1 minus 1 is how much? Tell me. 1 minus 1 is how much? 0. Are you convinced this integral is 0? Tell me something, Akash. Where are you?
Yes, sir. Yes, sir.
Yeah. So your integral is 0. The whole integral is 0. And I just go back and show you the expression. So your average x, and I did it for, see, if you see carefully, that although I had started with x1, but here actually I had put n, so maybe I can put n here. N. So I'm doing it for xn. So for in general, your average value of x for any value of n is 0. If I choose my particle in a box problem between the interval, so not 0, sorry, L by 2.
L by
interval, yes, between the interval 0 and L by 0 and L. Okay, convinced?
yes, sir.
So I have given you the argument, physical argument. Also, I have done it mathematically, and I showed you mathematical. So mathematics goes with the physics. The most important is the physics and also mathematics. Don't ignore. They go hand in hand. Okay. And physical chemistry means you have to know mathematics, you have to know physics, and then you have to know chemistry. It's a tough job. You have to know all the subjects if you want to become a good physical chemist. You are dealing with chemical system, chemical problems, but you're using the tools of physics and the language of any quantitative science is mathematics. So you have to use mathematics as well. So anyway, so the X average is L by 2. Okay? Is this clear?
Yes, sir.
So
Yes, sir.
let's now calculate Px average. What is the momentum of? Actually, you don't need to write partial because we are dealing with only the space parts. Yes. Now, before we calculate this, maybe physically, can anyone tell me that what should be the answer? What should be the Px average for this
0.
problem? Who is this girl? Actually I cannot see. Anyway, who are you?
Pooja.
Geeta Kumari. Geeta, you are in which course? Is it Geeta or you? Who is this guy? Sorry, the girl. Akash, and then there was one girl was there. She was still.
I am from MSc.
Geeta Kumari is from MSc. Okay, maybe someone else also. Anyway, so the point is that without doing the math, they just see if I can say what is the value of Px average without doing math. Can anyone tell me?
It will be 0, sir.
Why it will be 0? Okay.
Because in the one direction it will move in the positive direction of X in the same probability, and it also move in the same momentum in the negative direction of the X, and that's why the net momentum will be 0.
So the idea is as follows. Yes, what people are saying is correct. One good way of saying is superposition of whatever Choi and Patsu has written. But physically, you think, first you think classically. Okay, if I take a ball, put in a box, the box is such there is no potential, there is no force acting on the ball within that box of length L. So the ball will freely move. Only when it comes to the boundary, it will revert back, isn't it? It will go like this, because inside the box, follow my language, inside the box, the ball or the particle feels no potential, isn't it? So there is no preferential direction to go. It can go to the right, it can go to the left. And you are calculating something like average momentum, which is mass times average velocity, isn't it? So your average momentum you would expect in such a state where your potential energy is 0 or constant. There is no preferred direction to go for this particle. It can go to the right, it can go to the left. So on an average, what will be the momentum of that particle? When it goes to left, say when it goes from say towards the right, I call the momentum is positive. When it goes to left, I call the momentum is negative. But it has equal probability of going to the right as well as going to the left. And then I calculate the average. What should be the answer? We have already given the answer. The answer is 0. The average momentum has to be 0. So this is a case where the potential is constant or symmetric, so that the force acting on the particle is 0 and the particle has no preferred direction to go. You understand? Are you following? As a result of that, your average momentum for that particle in that state has to be 0. So even without doing the math, I should be able to show that, okay, if I calculate the Px average for any state, for any value of n, it has to be 0. This is without math. Now we'll do the math. We are convinced. Are you convinced? Are you convinced?
Yes, sir.
You are not convinced. So this is, you have to come from classical mechanics, classical physics. If I take a ball, put on a table, and then I have two boundaries, and if the ball does not feel any friction, the table is frictionless, and the table is straight, there is no force acting on the ball can go to any direction, isn't it? Isn't it? I release the ball with some velocity, some momentum, so it can go to the left, it can go to the right. It's free to move everywhere. So as a result, if I calculate the average value of the momentum is a vector. It has a direction, isn't it? So and the direction means it has a value either plus or minus. If the particle goes from towards the right side, I call it the positive momentum. It goes to the left side, I call it negative momentum. So as a result of that, I can say, okay, my average momentum of this particle has to be 0. Px average has to be 0. It cannot be anything. But if I put a particle in a potential, then the particle has some preferred direction to go, isn't it? And if I calculate the average momentum of the particle in that case, your average momentum is not going to be 0. You can see that in some future class. But the average momentum is 0 in this case, and you can show it mathematically now. Now let me see mathematically. If people don't understand, please go and read the books and think. Thinking is very important. So how do I calculate average momentum? Average momentum, I am not going to write the denominator. So what I'm going to write, so the average momentum for the nth state is.
Excuse me, sir. Can I ask something? Yeah, the average value of position should have to be L or L by 2.
L by 2. Why is L? It is between 0 and L, and the probability is symmetric around L by 2. It has to be L by 2. Sometimes you get some values which is greater than L by 2, and sometimes you get some values which are less than L by 2.
Sir, if you taken the same system and going to take from the 0 to L by 2, then what will be answer? It will be also similar L by 2. In both cases, it will be L by 2.
If it is 0 to L by 2, your function will also change. And then the average value would be again the midpoint, which is L by 4. You can do the math. If you take the length from 0 to L by 2, then your wave function is going to change. Your wave function is not going to be sine n pi x by L. It will be sine n pi x by L by 2.
Saying that if same function, if you think about the probability till L by 2.
Don't think about the same wave function, because your problem has changed. If you change your length from L to L by 2, 0 to L by 2, your length is L by 2, no longer L. So your wave function, you have L sitting there, you have to replace that L with L by 2. And that will give you a wave function, and then you calculate the average position. It has to be the midpoint. It is going to be L by 4. If the length of the box is from 0 to L by 2. But if I keep the length of the box constant, but if I choose my coordinate system in such a way that box is from minus L by 2 to plus L by 2. You understand? Minus L by 2 to plus L by 2. So the midpoint is at x equal to 0. Then the average position, if you calculate the average position, it is going to be 0. Are you following? It has to be. Go and check. Go do the math. I think many others are following, I'm sure. It is the midpoint of the box, that because your wave function is going to be symmetric around that point. You see that is going to be symmetric. Or not the wave function, sorry, the probability density. Probability density is going to be symmetric around that point. So as a result, your x average is going to be the midpoint. In this case, the midpoint is L by 2, and depending on the system we choose, your value should change.
Sir, what is the meaning of average x is equals to 0?
There is no average x equal to 0. It is L by 2.
So if we take the from minus L by 2 plus L by 2,
yeah. So
average x is equals to 0.
Yeah, nothing. Average x equal to 0. So you don't take that value so serious. That is your coordinate system. So average x equal to 0 means on and if I take an average on an average the value of x and find that to be 0 because it is symmetric around 0. In that case, it can go to the particle can be found on the right hand side of 0 and also on the left hand side of 0.
So then the particle exists there also, no? It
What?
does not mean the particle will not exist if average value of x is equals to 0.
No, every value of x is not equal to 0. So x average equal to 0 means what? You have say. So it basically means that you have enough number of negative values, enough number of positive values of x. And if you add them and divide it by number of measurement, on an average you are getting it to 0. You understand?
Yes, sir. Thank you.
That is what. Just go to your classical world. Essentially, that is what you're going to see. So let me do this first. Then we'll come back. So px average. So what is the answer? I know that I can take 2 by L outside because you get 2 by L and you get sine n by x by L, and then I have this IH cross operating on so I can also take this like common, no? I have to evaluate this integral. Now what is so I have to calculate ddx of sine this is the integral I have to calculate. Maybe you can calculate, you know what is ddx of sine x? What is the ddx of sine x?
Cos x.
Cos x. And what is the answer in this case? What is the answer in this case? Tell me what is the answer?
Cos n pi x by L into n pi by L.
So if you do this integral, again you're going to get it 0. Are you convinced that you're going to get it 0? So what am I going to get? I'm going to get, you can do it if you want. Because I think I will going a little slow. Should speed it up. Anyway. So this integral, I'm not writing the constants here, 0 to L, you will see that you get something like sine n by x by L into cos, right? If I differentiate sine, I'll get cos. And if I integrate this, I'm going to have constants here. So your answer is 0. So are you convinced that your answer is 0? If you have any problem, tell me. Any other way you can do this? Any other way you can do this? Maybe we can do some other way actually. Yeah, I will not do, but just you can do this. So next thing I'm going to calculate this. I'm going to calculate px square average for the nth state. What is the answer? What is the expression is going to be? It is going to be something like, I'm just writing it down. So you'll have 2 by L, which is going to come out 0 to L sine n pi x by L. And then I have actually what I have here, I have minus h cross s square, isn't it? What is px square? Px square operator is your minus ih cross pdx minus ih cross pdx. So your px square operator is nothing but I square is minus 1. So it is minus h cross s square. This. Essentially what I'm going to do, I'm going to differentiate this sign twice. Okay. If I differentiate sign twice, what I'm going to get?
Minus sin x.
So it is 2 by L h cross s square. I have differentiated this with the sine function twice. So if I differentiate this sine function twice, I'm going to get sine will give you cosine, and cosine will give you sine. Okay? But again, I'll pick up minus sign. And not only a minus sign, I'll pick some constant, which is n pi by L, but I'll get it twice. So I'll get n square pi square by L square times sine n pi x by L x. Okay. So this minus I take it outside. What I'm going to get outside is 2 by L into h cross s square into n square pi square by L square. Okay. And then 0 to L sine square n pi x by L into dx. Now can anyone tell me what is the answer? See, I'll show you how to get the answer. So if I take this 2 by L here and this integral, can anyone tell me what is this integral? Whole thing? This integral is nothing but
1.
because it is sin square x dx 0 to L, which is already normalized, is equal to 1, isn't it? Are you calling me that this integral is 1 if I include that 2 by L?
Yes,
2 by
sir.
L times sin square n pi x by L integration. So essentially what I'm going to get here is this. Essentially what I'm going to get here is, sorry, going to get here is n square pi square h cross s square by L square. This is your px square average. And if I calculate the kinetic energy, what is the kinetic energy? It has to be px square average divided by
2m.
2m.
2m. So this will give me n square pi square h square by ml square. If you see your notes, like maybe you already know that if I go back and I show you the expression for energy, remember the expression for energy? I had written somewhere. Maybe here, yeah, here. What is this? This is an expression for energy, isn't it? Actually, I should have put an n there because it depends on the quantum number n. I have done it here. So this is n square pi square h cross square by twice ml square. What you are getting here? N square pi square h cross square by twice ml square. So this is nothing but En. Is it surprising or not? Or it is expected? Tell me. Is it expected or it is surprising? Tell me.
It is a possible because potential energy is 0.
Yes. So inside the potential is 0, there is no contribution coming from there. So total energy is nothing but the kinetic energy. So that's why En is equal to the kinetic energy, average kinetic energy. Okay. So this is how it is. So now next thing I'm going to calculate and speed it up little. Otherwise, next thing I'm going to calculate is your x square average. So you have already calculated px square average. Then you have to calculate x square average. Now this x square average calculation is very lengthy. It is little lengthy. Okay. We'll just write down, but we'll do the math in the next class. So if I calculate x square n, you know this is going to be 2 by L. I will evaluate this. You will see that this x square average is obvious, it's not going to be 0. And what is the value of this x square average? We'll do it in the next class. But maybe next few minutes, I'll just show you one thing. You should have noticed that if I take this operator px square, if I take px and operating on psi of n, what am I going to get here? It is ih cross ddx on whatever, root over 2 by L sine n pi x by L, and that will give me what? Minus ih cross root over 2 by L. Now if I differentiate sine, what I'm going to get here?
Cos.
Yeah, cos or minus cos or cos?
Cos.
Yeah. So but again you will get n pi by L, of course. Take this and then cos of by x. But the problem is it is not in the form as a constant times psi of n. Is it in this form? No. Can you see that? So if I take px operates on psi n, I don't get that psi n back multiplied with a constant. Do you get that? Can you write down in the chat box? Do you get that? Yeah. So the answer is the psi n x is not an eigenfunction of px. But if I operate this px square on psi nx, what I'm going to get? Essentially, it is just nothing but operating px twice, isn't it? Psi nx. So what I'm going to get here? You get this, whatever is shown here. On first operation of px, you'll get this, and then again you have to operate px on this. So what I'm going to get here is actually again the constant I had was ih cross root over 2 by L n pi by L, and I had cos. Are you following? So I'll again now operate px on cos. So this will give me again n pi by L, but cos will give me minus sine. So it will give you minus sine of n pi x by L, but don't forget that we also have another ih cross. So I should have put here minus ih cross. Okay, so if I combine all this, so for example, if I combine all the constant, can anyone tell me what is the value? Ih cross will give me minus h cross square, isn't it? And this minus will combine. So what I'm going to get is n square pi
L
square
square h cut square by
divided by L square, and then I have root over 2 by L, and of course we have another root over 2 by L, which no, not root over 1 root over 2 by L, sorry, times sine n pi x by L. And what is this sine n pi x by L? Root over sine n pi x by L. What is this? So this is your
waveform.
psi n of x.
nx. So what I get here is actually the constant times this. Constant is so actually now it tells you that your px square for px square, this I n x is an eigenfunction of px square. Okay, so and also if you check, it should be also eigenfunction of this operator px square by twice n, which is your Hamiltonian operator, isn't it? Kinetic energy, which is you have only kinetic energy in this case, and this value is your px square value. And you see that since this is the eigen state, the eigen value and the expectation value, they are exactly matching, they are same. You go back to this, you see what is n square pi square h cross square by L square. So px square average is just same as the eigen value of px square. We'll stop here. So thank you very much. Just stopping here, and actually I think I'm going to stop the recording. Thank you very much for listening, and the next class is the day after tomorrow. We'll start from here and we'll evaluate x square average, and we'll talk about Heisenberg uncertainty principle in the next class, and again we'll revisit stationary state. So maybe I'll take 2 more classes to finish particle in the box, and then move to some advanced topic like say tunneling or something like that. But also I want to spend one class on linear vector space and Hermitian operator, properties of Hermitian operator. Okay. So what I can see here is that you have to have what is known as quiz, and the quiz will have it mid of September. So I'll let you know in few days the dates. What is the date for quiz, and email will come. So please wait for the email. By the end of this week we'll send the email, but tentatively it is the mid of September. Okay, and we'll have the quiz on Moodle. So all of you are on Moodle, no? You have checked Moodle. So we'll have the quiz on Moodle. So with that, thank you very much. People are asking questions, but maybe I'll stop recording, and then I'll answer your question. Thank you.